So one thing I wanted to kind of mention, going back one step, to transport of carbon dioxide, that when you're converting carbon dioxide to bicarbonate ions and hydrogen ions, as we described earlier on, the amount of hydrogen ions are going to determine pH of blood. And as a reminder, can you tell me what pH is? You should remember it from assignment 1, because we talked about it briefly there.
If it's acidic or
What's the opposite of acidic?
Alkaline.
Alkaline, yes. So kind of shows you, determines or indicates the level of acidity or alkalinity of a solution. So obviously in this particular case, our solution is blood. And can you remind me what the range of pH is? What's the lowest and what's the highest possible? Can you remember?
14.
Yeah, absolutely right. So it ranges from 0 all the way to 14. So is 0 more acidic or more alkaline? In what direction?
Acidic.
So this is exactly, so this is acid, and then 14 is going to be the opposite. Or base. So base is the same as alkaline. And the neutral is going to be
7.
7, exactly.
Is pH a small p and a large h then?
Yes, correct. So when you're typing it in your assignment, can you just take care and not type it incorrectly? Even if it's at the beginning of a sentence, it's little p and then capital H. So neutral is 7, as we discussed. So let's then think about it together. If I have a lot of carbon dioxide in my blood, is that going to create more or less hydrogen ions? So lots of this,
Yeah.
what does it mean in terms of number of hydrogen ions?
Will be more.
Will be more, exactly. So if I'm putting more ingredients into the system, I'm going to get more, of a product. So therefore, what's going to be happening to pH? Well, the rule is, more hydrogen ions you have, right, that's going to be making pH lower, more acidic. That means will result in, I'll write it down, will result more acidic. More acidic, or therefore low pH.
What's that say at the end of alkaline? Up, yeah, one
You-
base space.
Yes? Sorry, I wasn't sure which bit you were asking about. Have you figured it out now?
Yeah.
All good. And so what that means in turn, right? So if you have a lot of carbon dioxide swimming around in your system, which will then turn into more bicarbonate ions and higher volume of hydrogen ions, that will push pH to be more acidic. And therefore, that's why we need to continuously remove carbon dioxide when we're breathing, in order to not allow pH to go too low. Because remember, when I get to the lungs, this equation is going to go in reverse, and therefore the number of hydrogen ions is going to get fewer, and that's going to then rebalance pH level. And that's going to be a problem. So if somebody's having breathing difficulties, for example, right, so their cells are still producing carbon dioxide, but they're not removing it enough, therefore their pH level of their blood is going to start dropping. And this is going to cause a condition called acidosis, which is basically where pH is too low, and that's going to then disrupt other chemical reactions which are happening in your body. So that's why you need to basically breathe out, not just breathe in oxygen, but also breathe out carbon dioxide, get rid of it. You remember we discussed it briefly in assignment 1, where you talked about chemoreceptors, how they pick up the messages. So that's what your chemoreceptors are reading, essentially. They're reading the amount of hydrogen ions in your bloodstream. Okay? So when you're writing your assignment, can you try to link those equations to pH to show how pH is going to change with the amount of carbon dioxide as being higher or lower? Right, so that's the kind of add-on bit which I needed to talk about.
So the chemoreceptors detect a drop in pH.
They're going to just determine or check the pH, the amount of hydrogen ions, either if it's dropping or whether it's going higher. Right, so we can detect either.
But for this situation, it's a drop.
For a situation where you have high amount of carbon dioxide, then you have drop in pH, high amount of hydrogen ions, and drop in pH. And that's what's going to be then causing you to breathe fast, as we described in assignment 1.
Okay.
Switch this bit off.